Alright, I'm starting up the stream, so we're gonna get started here in a moment. What's up? Uh-huh. What? We'll help you when we get to needing it. We don't need it to the end of class. You just need to install Postman. Oh, you can probably skip that. If you can't just do API, it doesn't change the app at all. They're just surveying you. Okay, so we are done with SQL for now. We're moving back to regular code. I don't know of many people. I know of one student that liked the SQL, but I don't know many others that did. You liked it? Okay, there's a couple. There's a handful of you. The install problems were pretty rampant in our class, so that unfortunately ate a lot of time, which was a bummer, but SQL's pretty cool. We'll visit again later in a couple of weeks. Next week we do handlebars, I think, and the week after that we do SQLize, which is an ORM for MySQL. ORM is Object Relational Mapper. Basically, it allows you to use plain objects to query the database instead of having to write query text. So we'll play those a little bit again, and then obviously you'll use them in Project 2, which is 3 weeks from now. We're going to start that. So it's coming up pretty quick. You know, we're making our way through class pretty fast. So, you know, we're already over halfway done. It's downhill from here, I guess, in terms of time we got left. But anyway, Fist 5, how are people feeling about SQL? How'd they like that week? How'd they feel overall? Confident in their SQL abilities? Okay. Mixed reviews. Mixed reviews. Alright, well, like I said, we're going to address it again, and we'll hopefully be able to wade through some of those problems a little easier. But we're going to start talking about server-side again. Well, more in depth. Specifically building our own web server applications so we can host websites. So this is the week where we really get into building full-stack web applications, right? Because we're going to have our own APIs we're going to build. You're going to see how they work. And then from there, you're going to have the ability to host your own HTML. You know, you can host the apps that you've made already, like your portfolio. You could build a Node server to host that pretty easily, actually. Next week, we'll take it even further because we'll see an HTML templating engine, which basically says, you know, you can feed it some data on the server, and it'll automatically fill that data into the HTML so that, you know, you can have an application that it has dynamic content, stuff that's generated by the user, or, you know, hey, you log in, it says welcome username or whatever, right? Stuff like that. So it'll be pretty cool. But today, we're just going to start with real basic stuff. This whole week's dedicated to Express, which is a library in Node that makes it really easy to build APIs. So Node has some built-in stuff to allow you to build HTTP web servers. And you could use it raw if you want, and we're going to do it today, but it's a lot of work when you get into more complex stuff, so there's really not a reason to. Once you understand how it works, you're like, okay, great, we never got to do that again. And then you can move on to better libraries like Express. Oh, share is not what I meant. Present. So we have a quick little slideshow to go over, my favorite. And we're going to talk about the server side. So Trilogy's moment of caution to you is that this is really important. These are the most important concepts in the entire program. That's debatable, but they're pretty important. I think, honestly, the entire class is relatively along the same importance. And if you know, it depends a lot on what you want to get into after the class. If you want to get into UI design and kind of UX design, this is probably some of the least important stuff. It's good to know about it, but it really depends on what you want to do. It is pretty important, so you should keep that in mind, but what are we covering that isn't? So, yes, this is one that I actually wanted to, let's see if I can go back. Pluralsight. Has anyone used Pluralsight in this class yet? A couple people. Okay, good. So Pluralsight has trials that you can use. They basically have a bunch of videos where some professional or something will upload their content. You can go through it, and they'll have like lessons and stuff like that. And it's usually high quality content on Pluralsight. It's Udemy is hit or miss. Sometimes you'll buy a course for $10 and it's just garbage and it was a waste of money. Pluralsight's pretty much always good. There are some exceptions, but I've never been disappointed. Granted, I haven't used it a ton. So if you want to get a trial account, I would recommend you check it out. They recommend that you look at the Express.js Pluralsight course. It's supposed to be pretty good, and it can only help you augment your education on this stuff, because we can only go over it, so much in depth because we have such a short amount of time to work with you. And this is a good slide. I like this because the fact of the matter is we made it to week 13. There's nothing we're going to encounter now that you guys can't handle. Like, we've been through the thick of it. Yeah, we're going to be learning new stuff, and some of the concepts are a little bit more difficult, sure, but you've learned a lot. You've come really, really far. There's no reason why you can't learn anything else we're about to do. So, this is the point where you've made it far enough that you're going to finish, and you're gonna be fine, right? So, be confident. We're going through every week. It's still going to be hard. It's not like it's going to be easier, but you guys have been through it all now. So, so let's begin talking about servers. So we talked a little bit about servers at the beginning of this section, right? So after Project 1, we started getting into what is a server? What is all this stuff? Well, there's a few definitions of it. One, it's some physical machine somewhere in the ether. It doesn't matter where it is, but it's basically a computer. My laptop could be a server. Your laptops could be servers. These things could be servers, right? Because they have little computers attached to them. It's effectively just a machine in terms of the hardware, right? Now, what is a server in regards to code? It is an application that effectively gives content to a bunch of clients, right? So clients can go ahead and they can find a server and they can say, hey, server, I need something. And that server probably has some sort of API or interface to give those clients something back based off of their requests, right? So it's a request response model. If you're doing HTTP. But a server is effectively any code that sits on a computer that can give another program content. It's like the centralized application for serving content to a bunch of other applications. In a very general sense, that's what it is, right? Is anyone in here still a little confused about like what a server is, difference between a server and code, a server and hardware? Is anyone not really like they have something they want to clarify? I mean, there are things about this, about server code versus server machines, that questions you may have that I didn't even think of explaining. So if not, we'll just carry on. And if you have a question, just raise your hand and we'll answer it. So what are some examples of server-side functions? Well, when you visit a URL, every time you visit a URL and you get an HTML page back, you are making an HTTP GET request out to some web server that is giving you HTML as a response. Visiting an API endpoint that parses URL parameters to provide JSON. So, an OMDB API, whatever you're talking to on the other end of that AJAX request is a server. The Spotify API, I know some people use that. There's a server, several hundreds of servers for Spotify. Clicking an invoice that provides a PDF. So to get the PDF, you can't just magically create a PDF in HTML, and they can't just appear from nowhere. You typically got to go out to a server, and the server's got to send you that PDF, right? Image processing generally happens on a server, so every time you go to a website and an image pops up, that image is coming from the server, and depending on what's going on, it could be, resized, it could be compressed, something along those lines. Googling something, you're going to be talking with the Google servers, right? Because every time you search, they got to go out to all the crazy Google search servers and figure out what exactly you're looking for, find the best content, all that stuff. So those are some things that you can do. What is a client? So a client, just like a server, has two parts. There's a machine part and there is a code part. So the machine part would be any machine that communicates with a server, effectively. So my laptop, again, could be a client. As a matter of fact, it could be a client and a server. This thing is a client, right? Because it's connected to my machine through some video interface. So it's effectively a client displaying my video feed. Your phones are the most ubiquitous clients these days, right? Most of the internet traffic comes from these bad boys, so they're clients for a lot of stuff. And those are generally what clients are. Just really any machine that can talk to another machine, or does talk to another machine, is effectively a client. Now, what is a client in terms of code? An HTML page, right? Could be a client. Your browser is a client, and that's written with code, right? A browser is not a machine. A browser is an application. There's a lot of ways to view what a client is, and it's a pretty general term, just like server is. But in terms of code, we're going to talk about it as our front-end web page, right? Our front-end website. That is going to be our client, generally. The only time we've dealt with clients that weren't that is when we did the command line stuff with Node. Our client was the command line in that regards. And the server was, I mean, it's a little different, but the server was effectively the Node application, right? Not quite the same because they're not distributed or anything, but it's sort of what it is. So anyway, the client, think that is your website. Nice of you guys to show up. It's okay. I had to take the long way too. How do client and server communicate with one another? Lots of ways. There are lots of ways, but what we're primarily going to focus on in this class are the HTTP protocols, right? So there's a client. We'll make a request over HTTP to a server, an HTTP web server. They will send an HTTP response back to the client. So your web browser could talk to a Node application. It makes an AJAX request, a GET request, a POST request, whatever you decide. And then the Node web server does something with that information and sends you back a response. Now remember, if you really are into the technical parts of HTTP, there's actually an RFC out there that defines this entire specification of HTTP. So you can go read it. It's like 80 pages. It's pretty good, right? It's a really good read. Takes you through it. It's exciting. It's a page turner. If you're into the technical stuff, I recommend you could check that out if you really want to know more about requests and responses, because they have a very strict kind of structure to them. It's pretty easy once you learn it, and then you can really understand what we mean by request and response. They're just text blobs that are sent in this very particular structure, right? But that's how we communicate with HTTP. We have this request text blob. It has like the URL you're going to and the type of method, get, put, post, delete, patch, whatever. And then it has some headers and a body. You send it to the server, it parses it. There's a lot of text parsing going on, and then when it sends a response, again, it sends back a header portion that has where it's going, the status code, some header information, and then a blob, a body, right? So HTTP is real simple. It's just a text exchange over TCP, right? TCP is not as simple. And if you don't know what that is, that's the underlying binary protocol that communicates between machines. But don't worry about that too much, because you don't need to really understand it in depth to understand how HTTP works, right? So any questions on the client, server, how they communicate? I don't want to get too much into the technical side of it, because I can kind of mar the relationship we're trying to portray here and make it harder to understand. So I don't know if anyone has any questions yet. Great. So what can we do now? We've seen this picture like 50,000 times before, because they like to show it in every slide we have. Full stack development, that's what we're doing. That's what we're starting this week. For real, for real, for real. Well, we've done it a lot, but for real in the sense that we can now have a database. We can now build a Node API, and we can now build our web pages. All of it, every single piece of it, we can do after this week. And you are certifiable full stack developers after that, to the point where you have enough marketable skills that you could say, yeah, I'm a full stack dev. I know Node, I know the front end stuff, I know how to do MySQL. And then we're just going to augment those skills more and more as we go on with the rest of the course, right? But this is an important week for that in that regard. So full stack development, we have our user that they communicate with the browser, like we were just talking about. They use HTTPS or HTTP to communicate with some form of server, and on that server we're going to have, say, a Node web server that uses Express or something and communicates with maybe a MongoDB, a MySQL DB, something along those lines, and then generates some info and sends it back to the client.
Hey, is there a way we can get a copy of that slide?
This will be uploaded to the repo. This slideshow will be uploaded to the repo. They always are. So after today, it'll be in there. So let's dig deep into the server. So what does a server look like? I know Justin's probably pretty familiar with what servers look like, right? You've seen server racks. I'm sure you've seen plenty. So if you haven't seen a physical server, in regards to what we're talking about, when we mention things like the cloud, or say you have some sort of a server hosted on some service, right? Or maybe you have a data center somewhere where you send all your computers. They have these big server racks that are like, I don't know, 8 feet tall, sometimes 6 feet tall. They have a bunch of pretty crazy machines that are just pushed into the racks. And they're your servers, right? They're computers just like we would have on our desktop, but way more powerful, way more expensive, and stored way more compact, right? But this is kind of like a quick little picture of what it might look like. Imagine that thing's like 7 or 8 feet tall and got like $50,000 minimum equipment in it. That's probably cheap. A whole rack is probably $500,000. Or yeah, I mean, if you have shitty hardware, then it's so one box in the rack is probably $50,000 usually if you have a bad one. They're expensive, right? It's usually you put good stuff in there. So anyway, this might be what it looks like. So how do they communicate? Well, you have all these laptops. And they can communicate to the servers. I don't know what this is supposed to visualize for you. But yeah, they just they have arrows and stuff like whoa, you know, that's kind of how they communicate.
You don't have access to the server room.
Yep, users don't have access to the server room. Where do the servers live? That's a really open-ended question. So Amazon, for instance, they have their web services, right? And there's lots of, that's the cloud, right? And all the cloud is their abstraction over their data center somewhere that they have in the world, right? So Amazon's probably got like 10 major data centers. Yeah, you have a question?
I'm always been advertising here at Amazon Web Services classes.
Uh-huh.
Is that stuff that we do similar?
Amazon Web Services, we don't do any AWS here. When we do deployments to the cloud, we do it over Heroku, which is similar, much less robust of a service, but it's a pretty easy one to get your hands dirty with. Learning AWS is not a bad thing to do, or Google Cloud, or Microsoft Azure for that matter. As we get further in the class and we start doing deployments, figuring out how to do deployments yourself on those platforms is an extremely marketable skill. So I would check it out as we get a little further along and stuff makes a little bit more sense. But yeah, where do these servers live? They live wherever their data center is. But it doesn't matter to you, right? That's the point of these cloud providers. You don't care where the data center is necessarily. Sometimes you do. But you don't generally need to, right? You don't need to buy the machines. You don't need to manage all that infrastructure. These big companies are going to do it for you. And you can just rent, effectively, a piece of those huge racks. So we have this $1 million, $2 million rack or something that has all these crazy machines, you know, that have like 256 gigabytes of RAM per machine or something crazy. And you can rent a little space of that and run your little node service for 30 cents a month or something crazy, right? So they're really nice. They're really, really nice. And most of the time, I would say, this is what you're going to be using. You're going to be using a cloud platform to do your deployments and your infrastructure, because infrastructure is very expensive, hard to maintain. It's just not cost effective for businesses smaller than like Fortune 500 or close to that size, right? Because it's so hard to maintain it and so costly and, you know, dangerous, right? If you don't have good disaster recovery processes. So these servers don't care where they live. They just live somewhere. Server during development. Okay, so when we're doing development, like I said earlier, my laptop could be a server and a client. And oftentimes, we've already seen that. You know, that local host that we've played with a few times? That's basically your machine acting as a server. I mean, it is a server at that point. And thankfully, we have a nice mechanism for communicating with ourselves when we're building two parts of the application, the front end and the back end, right? And it's localhost that basically points to our local IP address that we all have on our machines. So while we're doing development, we can emulate both of them, and it makes for a really nice development experience because you can see how both would work. So, for instance, our Node applications will always be localhost when we're playing with them. When you deploy them to Heroku, then you're going to have a real domain name somewhere that you're going to have to communicate with. You're not going to be able to use localhost anymore. So, building a server. For our purposes, creating a server equates to writing the code that handles what the server will do. We're not going to be building machines in here. You can go ahead and do that in your spare time if you like, but I don't care about hardware, and I'm not going to teach it to you. It's important to note that even though you pay for server-side hardware, you still need to create the code that goes inside. We don't magically get code that can do everything we want it to do. Sure, there's a lot of code generators and stuff that can help you get going, right? Express has a template generator that you can use to generate a huge code base for you that has a lot of the framework for how you'd want to start an application, right? It's really nice, but it doesn't have any of the specific logic you would need. So if you wanted to serve a page that said hello and an error page that said oops, then great, you're done. But I'm pretty sure most people want more than that. So you got to write the code, and that's what we're going to teach you here. And what does this code do? Handles the database, handles dealing with URLs, parsing URLs. It does all kinds of server-side processing, image processing maybe, whatever you need to do. Authentication's a big one that we unfortunately don't cover enough in here, but it's a really deep subject, so it's kind of hard to cover it in a week even. And then logging client requests. So servers are really great because every client that communicates with them, you can find information about that client. You can log the information about what they're trying to do and stuff like that. So you can do a whole lot of stuff on your server because it's one single interface for all of your clients, right? So how can we imagine a server? Well, our server code, at least, we can start with an empty box, right? And this is like our blank Node application. We just did npm init. We created an index.js. We bring in the packages we need for an HTTP server, and boom, we've got this nothingness. First thing you got to do when you want your server to do anything is you got to listen. What does listen mean? Well, it has to do with the underlying OS mechanisms for listening over an HTTP socket, basically. A TCP socket with HTTP. So you tell your HTTP server, okay, we're going to start listening for web traffic, right? That's what we're going to do. It's the first thing you got to do. If you don't do that, your server's literally not running, so I don't know what to tell you. The next thing it's probably going to do is parsing URLs for requests, right? That's pretty important. Unless you have one path in your entire application, which is possible, you're going to have to do some sort of URL parsing. And even then, if you have one path, you might still have to, because it's possible some of the parameters in that URL string could change, and they could cause you to do different things anyway, right? So say you want to log in with a certain user, it's possible you could pass the username through the URL, technically, to do your login. It's going to do route handling. So if we have more than one URL that we want to parse, we're going to have to do routing. And routing is basically going to take that URL, it's going to figure out what exactly we're trying to do, and then you can think of it as a giant switch statement. It's going to say, if it's this, then case this, and we're going to do this. Case this, we're going to do this. Case this, we're going to do this, right? That's effectively route handling in a nutshell. It's a very simplified version of it, but under the hood, that's what Express and all these fancy route parsers and route handlers are going to do. And then the next thing we're going to probably do is send some HTML or send some JSON, right? So when you make a GET request, so we go to our URL, www.google.com, we're making a GET request to google.com, and it's going to either send us back HTML or JSON, or maybe even both sometimes, through several different subsequent requests that fire each other off. So what's interesting that people don't realize, and I've been trying to, express this all the way through the process, is when you get HTML back from a web request, it is technically no different under the hood than if you get JSON back, right? It's effectively the same mechanism. Everything's the same. It just so happens that our browsers have special code in them to be able to take that HTML and render them into something pretty on our, well, sometimes pretty, right? Into something graphic in our browsers, whereas JSON's just kind of this blob of information, so there's nothing to render there. That's all it is. You're getting text back that has this crazy markup format of HTML, and we'll see that today because we're going to be serving up our own HTML, and the code to do that's literally, hey, I found this URL, right? This is where they want to go. I'm going to go ahead and go to the file system, do fs.read file, find the HTML file I need, and I'm going to send it back over the pipeline. That's it. That's all your web servers do. It's really quite trivial when you get down to the nuts and bolts of it, which is surprising. It was for me when I was learning it. It seems, the funny thing about software is the more you learn, the more you realize everything's kind of just feels super kind of trivial and hacky, right? Like if you learn more about Git and how Git works under the hood, you're like, wow, that's all they do? That's really kind of dumb. If you learn more about an HTTP server, you're like, wow, they just send text over this thing, that's it? Well, it's really kind of simple, right? And that, as a matter of fact, is how a lot of things boil down to being quite simple, because frankly, if they're not, they're really hard to maintain and they often don't work. So, just a fact of life. So if we're not going to be sending HTML or JSON, we're going to be probably receiving some post information, put information, delete information, some of those other HTTP methods that exist. What do we do with posts and all that? We're generally changing data on the server, right? So a GET request isn't going to do that. It's just going to send some information back, but posts and stuff, they might change some data. So that's how you can change the state of the database or, update records or whatever. And then there's going to be server-side logic associated with all of that, right? So that's going to be any complex business logic you might have. Oh, when this user logs in, if they have this special attribute on their user record, well, then this has to happen. That kind of stuff has to happen in your Node application, of course. So those things are going to exist on the server as well. You want to put as much of your logic on the server side as you can, as long as it doesn't negatively affect the UI experience, which sometimes it does. And then you got to make a trade-off. The more logic you put on the server side as opposed to the client, the better, because it's in one place, right? It's in the same place. And everyone who makes a request to whatever endpoint, so say you have like a save order endpoint. Say you have some sort of ordering system, right? An e-commerce system, right? You want to save an order. If you have all the logic related to saving an order, validating the order is correct, and all that on your server, anyone who goes to save an order is going to execute that logic. However, if you put it on the client, it's possible there could be several places on the client where you can create an order, right? And all of them might not have that same logic. People might forget to put it there, which happens all the time. The reality is we're people and we make mistakes and we forget to do stuff. So the more you can put on the server in one place, the better, right? You can kind of get it all done at once and guarantee it's going to happen. And then there's even more we can do on the server, but we'll get into that later. Does anyone have any questions about any of this stuff? Anything we're going to talk about today? Anything regarding web servers and web clients or any of that? Now's the time to ask. I will take the fact that there is no one saying anything as no, so.
I have a question. You mentioned headers earlier. Can you say more about
Headers? Okay, yeah. So with HTTP requests, like I said, there's a structured text format to them with requests and responses. And part of that is, are something called headers. Headers are basically lines in that request and response that denote special characteristics about the request or response. So for instance, if you recall when we have script tags or CSS links, we'll say like this is text CSS or text JavaScript or something like that, right? What that does is it creates an HTTP header for the content type. And it sends that content type on the request and says, hey, when server, I'm looking specifically for JavaScript code. And then it can know on the server, oh, okay, well, this file I'm giving you has to be JavaScript. And we're going to treat it like JavaScript, right? We're not going to treat it like CSS. So I'm going to send it back to you. So they're basically just ways to define special characteristics about the request or response. That's all they are. They're like metadata. That's what they're used for. They have a few other uses with like authentication stuff, but it's effectively metadata. So, okay. Let us start coding. I'm going to pull up some code here. All right. So I'm gonna, they have an example one that will Slack out, but is now in your repo, so you can look at it if you want, but I'm gonna go ahead and just do it by hand. So we're in Node. I created a new index.js file, so we should be familiar with this process, right? on your machine. You create an index.js. To run it, we're going to do node index.js, all that fun stuff. Nothing has changed. However, instead of writing a command line application now, we want to write a web application, right? Something that works with HTTP. Well, Node so famously was used because it's so easy to write an HTTP web server. As a matter of fact, it takes like a few lines of code, trivial amount of lines of code, right? That's not HTTP. So, we have this line first. That should look pretty familiar at this point, right? Everyone remember FS? We did var fs equals require fs, and that's how we got the file system module out. So we could read files, write files, do whatever we wanted with files. Well, Node has a similar module for HTTP, which is very convenient, right? Because that's what we want to do. And that's what makes this so powerful and so good with web applications, is it's so easy to get to the stuff that you need to build this, build an HTTP web server. So we need the HTTP module. That's where we got to start. Nice and simple. Say we want to create a server now, okay? We want this HTTP module to create us an HTTP web server. Technically, that's all we really need to do. Now, it won't do anything, because if you look at the signature right here of this, it expects a request to listener, which is a function with a request and a response. So we need to handle the request. It's basically what it's saying. You need to actually handle this request. You can create a server, but I'm literally not going to do anything unless you handle the requests. So, that being said, we're going to handle request, right? This is going to be our web server in a nutshell. This one little function is going to do everything we need it to do to be a fully functional web server. Sounds crazy, but it's true. So basically what I can do is take this response, and there's a function called end. I'll explain a little bit more later. And you can simply do that, right? Hello world, or something you would console log, right? And we've handled the request and the response. We pass it in there, because this is a callback, right? We all remember callbacks? This is a callback. That's all it is. Now, when we looked at that box, right? We were talking about that box of things that are our server. Before we imported the HTTP library and we had nothing, that was the empty box. And then the first thing that came up when we did that, when we were going through the different things that can happen in the server, was listening, right? So while we have some of the stuff in here, we have technically handling the response and request, sending back some HTML or JSON. It's neither of those, it's just text, but it's effectively what it is. And we have the server. We don't have anything listening yet. Conveniently, there is a function called listen. Wow. That will do our listening. So what we have to specify first is the port that we want to host this on. Remember how I said when we're doing development work, our machine is going to be both the server and the client, and that's what we're going to show right now. So our host is going to be localhost by default. So don't worry about everything you're seeing here. We need a port number, and one that people typically use for development is 8080. There's a reason for that, and I'll explain it. We'll go through this after we get it working. And then we need another callback, which is our listening callback. And we can say we are listening on port 8080. And we have ourselves an HTTP web server, believe it or not. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 lines of code if you count the opening and closing curly braces, right? It's really not that much. I go ahead and I can open my terminal. And I do node index.js, and you see listening on port 8080. Now notice it doesn't exit. In our command line stuff, it would run and then exit, and then your terminal prompt would come back up, right? It did not come back up. It is still running. It is just running. So I want to verify that this bad boy is indeed running. If I bring over the browser and I go to localhost 8080, you see I get hello world. Let's see if it'll give me the nice, cool. There we go. There we have it. We have a web server. If I want to end this in the terminal, Control C. Boom, dead. Now if I try to do it, it's gonna freak out. Oh man, that's not good. Pretty cool, huh? We just built a web server. It's really easy. Now let's add something to this response really quick so we can pay attention to a little bit more of what's going on. And we can actually take the request and we can interrogate it for the path that's coming into the application. Okay? So if we take request URL, we'll be able to see the path that we're putting in our browser that this is picking up. So we'll start the server again. I get a slash, hello world slash. Yeah, Andy?
In the example, it's creating a variable for that port that's not necessary.
No, I mean you can create a variable, it's easier to manage, but it's not necessary. You're just passing it into the function, right?
Okay.
Yeah?
Alright, ready. Put in the URL.
Brings you a what?
You have your server running?
Yes.
No, I haven't.
You started it. Put
I'll look at it in a little bit. We'll look at it after this example.
Yeah, put colon 88. Make sure you got a colon between localhost and 88.
Yeah, there is a colon. Localhost colon 880. Anyway, if I go to, you'll notice that I don't actually have any path after the localhost 8080, but it's still coming in as a slash. That's because the default path for all URL requests is just a slash after the host name, right? My host name is localhost, my port is 8080, and after that my path is just slash. That's like as low as it gets. There's no path less than that. Just the browsers are friendly, and so they just truncate it when that's all there is. They just get rid of it so they don't show it in the address bar, but that's what it is. So now if I go here, /test, my hello world comes back with a /test because my URL in that request is /test. Any other questions on this bad boy? So let's go over it a little bit more in depth. There's a couple things I said I wanted to talk about. So we have our listen function, and I said let's start with port 8080. That's a common development port. The reason why is port 80 and below, well, everything below port 80 is a reserved port for very special programs on your computer that you can't take. So port 23 is Telnet, 22 is SSH, 25 is SMTP, things like that. 80 is the first port where you can host a web application. I don't know why 80, it just is. They just decided 80. I don't know the history behind it. There's some reason. Do you want to do 80 though? No, you don't. Not in development. You're fine doing 80 if you have a machine that's sole purpose is just to host this application. Then you're going to need to use 80. Because you'll have a DNS name and all kinds of other stuff that's going to happen. But for development, you don't want to use 80. And same server machines, if you're serving your client on the same machine, you usually don't want to use 80 either. So that one's also a special port. So what port do you want to start at? Generally, the lowest you go is like 3000. There's a certain number where you don't want to go under those anyway because it's possible there'll be another application that's using it. If you really want to be safe that no one else is going to be using your port, go above 10,000. And you can go up to like 65,536 or something. Something like that. It's basically an unsigned 16-bit integer is all it is. So if you know how long those are, then you know how high you can go. But if you pick a port 8,000 and above, 10,000 above, you're never really going to have a conflict. So those are safe ones to pick for development. Because if you get a conflict, it's no fun. For instance, if I try to run this again, I get a crazy explosion, and it says e-adder in use. So And then it gives me 3 colons and an 8080. It's saying that port localhost 8080 is already being used by another application. You can only have one application at a time running on a port. That's why this is all important, right? Because the machine is under the hood, it's listening on that port for that specific application. If you had multiple applications on the port, it wouldn't know who to send the traffic to. It'd be like, I don't know where this goes. So you can only do one at a time on a port. So if you ever get this bug right here, this little explosion, listen, e-address in use for that port, it's your application is probably running somewhere else. So you either have it running in another terminal or it's running in the background on Windows sometimes. If you mess up and you get a crash, it's possible to just be running in the background and you'll have to go into your task manager and actually delete the node process. So that happens. But word of the wise, start with 8080 and move on up. Sometimes you'll see port 3000, like I said, sometimes 5000, but yeah. Adam?
443 is for the secure.
443 is HTTPS. 389 is LDAP. 636 is LDAP-S. Yeah, there's a bunch of random ports.
So like when I leave the server, I do the HTTP, but then later when I want to use some kind of hosting, then I can decide if I want to use 80 or 443, right?
Yes, so that's a good question. So 443 is where HTTPS communicates, right? So 80 is where HTTP goes, 443 is HTTPS. So I'm doing development, I have everything on port 8080, but I deploy it and I want it to go over HTTPS. So I need it to be hosted over 443. What typically happens is your node server is not what's directly exposed to the internet, so you'll give it a weird port, like, I don't know, 5000 or something, and then you'll have another web server like Apache, Nginx, IIS or something that actually listens on port 80 and 443, and what it's called is a reverse proxy. So when I go to that machine and I make a request, the machine's going to say, I know when traffic comes to port 443, I need to reroute it to my node application at port 3000. So usually do something like that. So yes, at deployment time, you can decide if you want to deal with those things. But at dev time, don't worry about them.
You have to get some kind of package with that specific HTTPS.
Totally different can of worms. We'll talk about it later.
Okay.
No, you don't. You don't want to host this raw HTTPS.
Okay.
What else is going on here? This handle request is taking care of our headers, our HTTP traffic, all of that stuff. So this response end is by default sending a status code of 200, and it's sending some response headers back. And the browser is going to send some default request headers too. So if I actually go here, and let me open this in Chrome, since we're all more familiar with Chrome. All right. So I go here, I can hit F12, escape. You can actually go to network here. Let's see if I can blow it up. Come on. And if I refresh, you'll see I have a request and response from localhost port 8080. So this is that request and response I was talking about. It comes back with a status code 200 because that response.end automatically just sends a 200. That's the default status code it's going to send if you don't supply one. And then there's some headers. So if we look at the response headers, we actually look at the response itself. Let me see if I can get the raw response. Okay, so this is a raw response right here. This is the header portion of it. So we have HTTP protocol type version. We have the status code 200, and we have what it means. We have some data information, and then there's two headers. One that says connection keep live, and one that says content length. This is what the response header section looks like. And then there's an empty line, and then it's going to send back the content. And in this case, the content is this text. And then our request headers, we have a bunch, actually, because the browser is going to send a bunch by default. So we have an accept header, which tells you what kind of content the browser is willing to accept from the server, which this doesn't specify any, but that's okay, because it just says **, so it says anything. It has special encoding information, language types, so my default locale is English in the US, cache information, connection information, the host it's talking to. So this is basically the structure of our HTTP request, and this is the structure of our response. So you can actually see them in Node, which is really nice because you're going to need to as we get further along. But this stuff is all handled by Node, which is what's so amazing. If we, again, go look at this code, just these 8 lines of code has done all of this stuff for us, right? With a combination of the browser and Node. What was that? How did I see that in Chrome? You hit F12 and you go to network. And then you refresh. You have to refresh the page, though, after you have the network tab open, or you won't see any of it. All right. Any other questions on this and how it works and all the fun things we're doing? Cool. So we're going to go ahead and do an activity. The activity is activity number 2, I want to say. Yeah. And what you're going to be doing in this activity is creating 2 servers, actually. So in one Node file, one JavaScript file, you're going to be doing this twice. Remember, it has to be on 2 different ports. You're going to listen on both, and then I want you to ping both from your browser. Whatever your phone is,
I'm just wondering, what's the sequence going
put in your address bar, colon, no spaces.
You guys know for pulling up.
Because the process is being run,
But
My 7500 was 7,000. The same one that was making I'm like,
Well, you have to run them. They all have to be run independently. Put the 7,000 and 7,500 in the same file. Put them both in there. Yeah. Not all of it. You don't need the HTTP. You don't need the. You're gonna have to do the HTTP server again. All that stuff.
Yeah, I got one of them, but can you use the same thing and then it's when you said that you just got a function, what do you mean by the same browser?
Save.
So
that's what I was thinking right now, like, instead of being like, I don't want to.
And they should make if you have two of them. Yeah, they're different variables. You need to use the same variables. Your server there, that's a different file. They're in the same file.
This is it for me. So you have to do the first.
Yep. It won't just restart with all the new code.
So I realized I only did the node for my other.
Yeah.
Thank you.
No problem, man.
That's what I did do. Yeah. So you don't need that. So you only need those two. two separate ones. So I built small lines and stuff
You want to put it towards the top? Yes.
All right, let's go over this one. Okay, so the first thing I'm going to do, as Andy pointed it out, the examples had the port in a variable. So since we're going to have two servers in one application now, it's a good idea to just do that. Put them in variables, right? Because then I can do var, port 2. I can make it something totally different so they can have both ports, just a nice easy variables to get to. So for this particular example, they wanted 7,000 and 7,500, right? So we have our server. We could launch everything on port 1 and be good to go. Port 1. We can do our fancy string interpolation. Right? And we should be good. So if I run this thing on port 7000, I can go ahead and go back to 7000, and it's working. Okay, great. But I need another server. Well, I have to literally create another server. Copy this console log so we know that it's running. So now, if I run my code, I get listening on both ports. This one's still working because I can refresh. Let's try 7500. Also working. Cool, I've got two servers, but now the only problem I have is the requests are the same, so it's hard to tell that they're different. So how can we make the requests different? Well, we can build another handle request method. We could make a handle request 2, says hello world from port whatever. Or if we want to be fancy, we can build a builder function that will just return this function. Remember closures and higher order functions we talked about? So what this is going to do is return another function that will handle our requests for us. And we just have to tell it what port we're dealing with, and it'll tell us what port we're on. So if we do this, we do port 1, port 2, right? Let's run this bad boy. So this one tells us we're at port 7500, and this one tells us we're at port 7000. So now we have a distinction between the two, and we don't have to write a whole lot of extra code, right? We don't have to write a whole other method that's effectively duplicate. Now, if you want your second server to be totally different, well, that's a different story altogether. But then you'd want to build a second routine and all that stuff. And it's pretty uncommon, too, to host two servers from the same file. I think the point here was just to show you how easy it is to spin up a server, and that it's possible. Yeah, question?
What three do you mean exactly on lines 16 and 20?
16 and 20? Oh, string interpolation? Okay, so see the backticks here? Instead of being surrounded by single quotes, this string is surrounded by backticks. Okay? So that's just above your tab key. And then if you do $, open curly brace and closing curly brace, you can put a variable in, and it'll automatically put that in the string. So instead of doing like plus, whatever, yeah. It's just a much faster way to do it. So.
I wasn't sure if that was like jQuery or something.
Nope, that's just built into JavaScript. I showed my class a few classes ago, and they had a bunch of questions about it too. So. Yep. Yep, it automatically turns it into a string. It's just a nicer way to do it, so you don't gotta do all the pluses and stuff. Like up here, I could change this one to string interpolation, and it would just be, you know, hello world, $ curly brace, request to URL, curly brace, from port, $ curly brace, port, curly brace, right? And then with the backticks around it, and you get the same thing.
Is there ever a reason you wouldn't do that and you would do it the first way?
If you needed to dynamically concatenate a string, so if you had a bunch of stuff that you needed to add up in like a loop, maybe. Otherwise, you could still probably do it with that, so no. Not really.
Well, I tried to do that string interpolation for the like SQL queries, It wasn't really working like for that.
Okay. You'd have to show me what was going wrong, and I could try to help you out
Yeah,
there.
there's just like so many like quotes and stuff that I just I don't know.
Yep. Yep. It can get confusing. Yeah. Question.
When I try to access it on my Chrome, I get like a strange sort of link in it. Actually,
Is it you verified that this is running?
yeah, I didn't know. Listening to it.
And what are you typing into the browser?
What's the whole 7,000 and 7,000?
At the same in the same address? No, in two different tabs.
Alright, port 1.
Not necessarily. We'll come look at it in a moment and try to help you out. I don't know if one of the TAs wants to look at it and see why it would be loading forever. Any questions on this code though? I'll send you out the example the Trilogy provides, and I'll Slack out my version of it too, so that you guys have two examples of how you could do this exercise. Any other questions on this before we're going to move to the next exercise? Alright. I'll Slack these out real quick. There's the provided solution. And here's my solution. Alright. So, if no one has any questions, what we're going to get into now is parsing a URL and returning HTML. Building an HTML web server, right? So we can have little web pages and stuff. So I'm going to just eradicate my double server stuff. Actually, it might be better, yeah. I'm just going to get rid of this. I slacked out the example. Clean this up real quick. All right. So one thing you'll see often are abbreviations in code for these things. You'll see rec and res. Rec, request, res, response. Because in the Node community, they're super lazy. So especially when we start doing express, rec, res is what you'll see in all the handlers. So what we're going to do now is we're going to take a request. We're going to read the URL that comes in, the path, and we're going to decide what to do based off of that path. Okay? So, how can we do that? Well, we already saw how request.url exists, and it shows that path at the end of the URL that we've got. So really simply, we can just do a switch with our path. We can do a case on the default root, right? And then portfolio. Let's create a path for portfolio. And then let's create a default case that we're going to give like a 404 or something. Okay, so these are going to be our routes, our available routes. And effectively this is all a web server is doing when you send a URL in, and it's finding what HTML or JSON to send you. And obviously it's more complicated than just this, but at the end of the day, this is what it boils down to. So, how can we return HTML? Well, let's try for home really quick. I'm going to pass rec and res into this function called display home. And display home is going to, I'm going to just copy this. Basically send back some HTML, real simple HTML. Now, to properly send the HTML, there's a couple other things we got to do. We can't just do the res end. So we're going to eventually need res end. And instead of passing in some random text, we're going to pass in that HTML text, okay? But for the browser to properly render it, we have to get into those headers that we were talking about earlier. So there's actually a function called writeHead. You give it a status code, which starts at 200. That's the default, and that's when we want to send. And then we can specify the content type, which is just going to be text HTML. What this is going to do is add to the response that content type text HTML header. The browser is going to know that the content it's getting back, that text string, is HTML, and it should render it like HTML. So if I just call return display home and pass rec res in, we should see some HTML. I will go ahead and stop this. I will rerun it. Listening on port 7000. If I refresh, I have HTML. And that's really all there is when it comes to displaying HTML from a Node server. So now if I click here, you'll notice that it spins and it spins. It spins and it's like, oh, I don't really know what to do now. There's a reason for that. We'll get into it in a moment. So notice that this case is looking specifically for the path of the default slash, right? So nothing. When I did slash portfolio, I clicked on this, which is an A tag, which you can see down at the bottom. It's hard to see for you guys, but it says it's going to redirect us with the A tag to slash portfolio. It's going to enter this handle request. It's never going to find anything. And because res end is never called, I'll never get a response back. So if res end is never called, you'll never get a response back to the browser, and the browser will load forever. And your server effectively is trying to send a response forever. So res end has to be called if you ever want a response back. This is why it gets kind of irritating with just raw Node HTTP, because there's a lot of rules of things you have to do as your application gets more complex. If I call res end twice, I'll get a bug because we already sent the response. It's already done. So also can't do that. You gotta call res end. So anyway, portfolio, how do we handle that? Let's create a function. Portfolio. We'll create a display portfolio, which is gonna do effectively the same thing. Except this one is going to return a page that says my portfolio and has an href back to the empty path. It says go home. And then I just return display portfolio, res, pass in my rec and my res. I don't need these breaks because I'm returning. So if I restart this server, now I should be able to refresh, go between the two pages. Full URL navigation and everything now. This thing is getting sophisticated. Alright, what's the last thing we want to do? Well, those are the only two paths we have, so it's pretty natural in a web server to basically say if this path is unrecognized, we're going to say 404. You know, we don't like what you're giving us. It's not a legitimate path, so that sucks. So let's create a display 404. This one's actually going to take the URL in and say, hey, whatever you're looking for doesn't exist. Notice writeHead is slightly different. Instead of 200, it returns a 404 status code. So the status codes, what do they actually mean? Well, they're just kind of a descriptor for the client to know how to handle that response. They don't actually change what the browser does necessarily, but they allow your client to be more responsive. Okay, I got a 404, I should redirect to something. I know that this is a bad request, something along those lines. So right here, we can return display 404. We can send in the path, rec, and res this time. It's going to be slightly different API for that function call, right? I can refresh. So let's make sure this still works. Okay, we can get to those. I go to /test, not found. The page you're looking for, /test, cannot be found. Pretty cool, I think. Right? You guys could take your portfolios that we started at the beginning of class now, and you can literally build a node server relatively trivially to host that for you. So that's pretty neat. Any questions on this code right here? How it works? Cool. If one of the TAs could slack out the Trilogy version of that. It's activity number 3. So you technically have this in GitLab, so you can go look at it if you hadn't been already. But we'll slack it out for you so you can look at it a little bit more. What I want you to do is just spend a couple of minutes, not too long, maybe 5 or 10 or so, and take that file we were just working on with the 2 servers, or even just take an example with 1 server and serve just a little HTML. Have one route that serves HTML and one route that does like a 404 or something. Just try to do that with your group and kind of discuss what do you think's going on. Kind of discuss as you're building this to your partners how you're going to build this and how it's working, right? So spend about 10 minutes doing that. You're probably not going to finish, and that's okay. This isn't technically an activity. I took their activity to just discuss, but what does that really do? So we're going to do that, and then we're going to probably go to lunch. Already, yeah, this is a Monday class. So,
Monday, is that Labor Day?
yeah, because we're still off. So this is a Monday class.
Damn, that
Nope,
Labor
we're not getting out early because there's extra content at the end. So,
Day. Those holidays.
extra content.
And those holidays. Normalize Thanksgiving. We're gonna have like a break in Thanksgiving, right?
Nope, you got to be here Thanksgiving. Christmas and New Year's too.
Oh.
Hey Carson, can you slack out your version of what you did?
Here?
Yeah, some people want to see what you want on top of what you did for the your solution.
I'll work. I gotta work. I work Sundays, Thursdays.
There you go. Slacked it out. We're gonna reconvene at 12:15. So if you feel like you understand this and you don't want to spend time on it, go to lunch. Be back at 12:15. That's the only rule. 12:15. It's 11:30. So.
So we can either work on it or go to lunch.
Yeah. Just be ready by 12:15 for the next content.
So if we work on it, we don't get lunch. That's all I have to say.
I had
I'm gonna end the stream and then I'll start it up again at 12:15.